Hey everybody, today we'll be introducing and exploring the concept of pH, which stands for power of hydrogen in a substance. It is measured on a scale of 0 to 14, with 0 being the most acidic and 14 being the most basic. For example, a battery would be placed at a pH of 0 because it is very acidic in nature, whereas bleach would be placed at a pH of around 14 because it is very basic in nature. But what makes something acidic or basic? For something to be acidic, it has to have a large power of hydrogen. In other words, its concentration of H plus ions is very high, and its concentration of OH minus ions is lower. The opposite exists for something to be basic. It has to have a low power of hydrogen. What this means is OH minus ions are high and H plus ions are limited. As a result, since concentration helps determine how acidic or basic a solution is, it can therefore be used to find pH or pOH. It is important to remember pH is the power of hydrogen. On the other hand, pOH is the power of hydroxide. It's very important to remember this. Also, it is worth noting square brackets mean concentration. So the following formulas will be used in calculating pH. So we have to remember pH is equal to negative log. Square brackets means concentration of H plus. That's one formula. The other formula we might need is pOH. How to find that? Remember, before I said pOH is related to hydroxide, so you find the concentration of hydroxide. And the last one, when you add the sum of pH plus pOH, you should get 14. These are three important formulas that you might need while we dig into this concept. It is also good to know that pH is a dimensionless quantity. Therefore, it generally has no units. And the units for concentration are either mole per liter or molarity, which is M, capital M. Another important concept while working with pH problems is to find concentration using pH or pOH. This is also done through different formulas. So the main two formulas that we might need to solve these type of problems is 10 to the power of negative pH, which is what we have, is equal to the concentration of H plus ions. And the other formula is 10 to the power of negative pOH, and that is equal to hydroxide ions. So these two formulas right here help us find the concentration using pH and pOH. Let's wrap up this session by looking at one practice example building on this idea. So the example we have here is find the pOH of a substance with a pH of 3.50 and subsequently find its OH minus concentration. Let's now work out this question. So first of all, we need to apply the formula pH plus pOH is equal to 14 from before. Now when we sub in, we get 3.5 plus pOH is equal to 14, where we've subbed in a pH of 3.5 from the question. Therefore, when we rearrange pOH, we get an answer of 10.5 as the pOH level. Now, using this result of pOH is equal to 10.5, what we can do is, using the formula, 10 to the power of negative pOH is equal to the concentration of OH minus, we can sub in our pOH value in and find that 10 to the power of negative 10.5, because that's our pOH value, is equal to 3.16 times 10 to the power of negative 11 to two significant figures, which is the OH concentration right there. And because this is concentration, just before we finish off, make sure to include a unit of mole per litre. I hope this introduction to pH was helpful to build your knowledge on this topic. And once again, thanks for watching. It means a lot to me. See you guys later.